Hi everyone, I'm Jim. I'm going to be reviewing statistical power. I'm going to pull up some slides for you and we'll run through it. So statistical power is the probability of rejecting the null hypothesis when a specific alternative hypothesis is true. Or more simply, if there's an effect in the population, it's the likelihood that we're going to find it. So the first thing when we're looking at power, we look at the beta. Probability of the test will not find an effect that exists within a population. So our power is 1 minus beta, and we tried to limit beta to 0.2, or 20% chance of not finding effect that does exist in the population. Therefore, power should be around 0.8 or more, meaning there's an 80% chance of detecting the effect if it exists. So factors affecting power, first we have our alpha level. So depending on where we set our alpha level, we could vary our power. A study with an alpha level of 0.10 in this instance has the greatest power because it has the most likelihood that you will find the effect if it exists within the population, even if it means we're increasing our chance of a type 1 error. So the factors affecting power, magnitude of the effect size. So the larger the effect, the more power. As a teaching and admin student, I might study socioeconomic status of individuals and number of students in each class graduating from small private colleges. I would expect a large effect size because, through a review of literature process, theoretically, I would find that I might find that socioeconomic status is generally highly correlated with graduation rates at small private colleges. On the flip side of the coin, a study that doesn't expect such an effect size based on literature and etc., the effect might be harder to find. Therefore, the power is going to be smaller. So factors affecting power number 3, perhaps the most obvious, is sample size. The more subjects we have, the more power your study is going to have. So this is where most researchers will run into a problem. On one end, too little subjects may not have enough power to carry your study. Your effect, you may see an effect, but it may not be significant, or you might not find an effect at all. Whereas on the other end of the spectrum, if you have too many subjects, you may find an effect that really doesn't exist, and that's where your type 1 error comes into play. So factors to consider when considering power is research design. So a theoretical question that highlights this is, do students learn more efficiently when teachers post slides before or after class? Study 1, the same students were introduced to both approaches, tested and compared. Approaches being slides before or slides after. Study 2, 2 independent groups of students were introduced to one approach, each tested and compared. In this instance, study number 1 is going to have the greater power because it's within subject's design, limits subject variability. So when do we calculate power? The most common power analysis that we'll run into, or the most relevant to us, is a priori power analysis. So this just means before the fact of the study, we calculate power. And this allows the researcher to set up a study that will hit statistical significance or statistical power. And on the flip side of the coin, after the fact, the post hoc power analysis is done when after the study. So when we know the sample sizes, the effect sizes, and the alpha level. This could be explained to use non-significant differences. So basically, there's a difference in 2 data sets, but if our power wasn't very high, then we could say maybe this difference was due to our small power size, or the difference not existing. That's pretty much all I have for today. Thank you so much for listening, and I hope this was helpful to you guys, and I'll see you soon.